This one's going to ask us to calculate the copper 2 plus concentration remaining in 335 milliliters of a solution that was originally 0.215 molar copper sulfate. And this is going to be after the passage of 2.17 amps for 235 seconds. So the first thing that we need to try to find out is how many coulombs do we have being passed here. Because we can take the coulombs, relate that to moles of electrons. We can then take those moles of electrons, relate it to moles of copper. We got a volume. We can calculate a concentration. So we have 2.17 coulombs per second. We are passing that for 235 seconds. So our seconds cancel out. We have our coulombs. We know that 1 mole of electrons is equal to 96,486 coulombs. In this passage, we have copper and copper 2 plus. So we're going to have 2 electrons, or 2 moles of electrons for every 1 mole of copper 2 plus. So this is going to equal 0.00264 moles of copper 2 plus. So what that means is we have an initial solution that contains copper sulfate. Copper sulfate is going to completely dissolve into copper 2 plus ions and sulfate 2 minus ions. If we perform an electrolysis experiment, that copper 2 plus can be plated onto a solid, in this case copper. When we pass that current, as time goes by, this nice dark blue solution is going to get lighter and lighter and lighter, and there's going to be more mass deposited on our electrode. So as we go on in this process, we find that 0.00264 moles of copper 2 plus are going to be plated in our time interval. If we divide by our concentration, we get 0.335 liters. So we can calculate a concentration of copper to be 7.89 times 10 to the minus 2 molar in copper 2 plus. Now let's think about what this value is right here. 7.89 times 10 to the minus 2 molar copper 2 plus is the concentration of copper 2 plus that was converted to copper solid. Is that what this question is asking us? It's not asking us that. It's asking us, what's the copper 2 plus solution remaining? So our copper 2 plus solution that remains is going to be equal to our copper 2 plus solution initially minus the copper 2 plus solution that was deposited. So the copper 2 plus solution that's going to remain is going to be equal to our initial concentration, which is 0.215 molar, minus 7.89 times 10 to the minus 3 molar, and that's going to give us a copper 2 plus concentration that's going to be equal to 0.207 molar. And we could perform this electrolysis reaction and perform it and keep it going and going and going until that copper 2 plus in solution diminishes. Yep, question?
Was it 10 to the minus 2 or 3 up there?
It should be 7.89 times 10 to the minus 3. Yeah. So if you do the math properly, that's what you get. And then when you subtract that, you get this value.